1985 BC 14, whereas which of the following series are convergent? And these are some pretty typical types of series here. The first one is a p-series. With a p-series, you have n to the p power in the denominator, 1 over n to the p power. So p-series, 1 over n to the p power, where p has to be greater than 1 to converge. And we can see here that this one, p is equal to 2, and so we say converges by p-series test. P is greater than 1. Alright, the second series is the classic harmonic series. And we should know that the harmonic series, it diverges. And so the first one converges, the second diverges. The third one looks like a p-series, but it's even more than a p-series. It's an alternating series. And so this one converges by the alternating series test. Again, 3 criteria for the alternating series test. It strictly alternates. Second, the terms decrease in value. A sub n plus 1 is smaller than a sub n, and you can see that 1 over 3 to the first power is smaller than 1 over 3 to the second power. 1/9. The successive term is smaller than the previous term, 1/3. Again, we would need some more elaborate proof methods to prove that, but we can see intuitively that it is true. The terms are decreasing in value, and finally the limit as n approaches infinity of the nth term has to be 0, and so 1 over 3 to the nth power. Now, I think that I said that this was a p-series. This is not a p-series. This is more like a geometric series. I apologize. Notice the one above where the 2, 3, etc. n, the base of the denominator is changing, but here the base is staying the same and the exponents are changing. So that is the telltale sign of a geometric series. In this case, r would be equal to 1/3, which is less than 1. Absolute value of r being 1/3, less than 1, so it's going to converge by the either the alternating series test or by the geometric series test. And r is not 1/3, r is probably negative 1/3 here. But the absolute value of r is still less than 1. So again, we could have used either test here, the alternating series test or the geometric series test. Remember, this is not, though, a p-series. A p-series, a classic p-series, would be not in example Roman numeral 2 above, but in Roman numeral 1 above, where the bases 2, 3, 4 are changing, but the exponents 2 are constant. In this case, we have the base being constant, but the exponent changing, and as I said, that's a classic geometric series. So the third one is going to converge, and so we have the first and the third only converging, but not the second. We'll stop here.